All right, so we've talked about atoms, how they're made of those subatomic particles, what happens when those numbers of particles change. Now let's look at compounds, the other half of pure substances. Remember, compounds happen as a result of multiple different elements coming together. We're going to see, generally speaking, we can break compounds up into three categories, two of which are pretty easy to identify, and the last one is kind of in between. So those first two, the easy ones, are called ionic compounds and molecular compounds. Sometimes you'll see molecular as what are called covalent compounds. Covalent. And the difference is that ionic ones are made of ions. Typically, although there are exceptions, typically this means that they are made of a metal and a non-metal. Typically. So they are made of metals and non-metals. There are a few ionic compounds that do not contain metals, but they are still ionic, and we'll look at those as well. Molecular compounds, by contrast, are non-metals only. And we're going to see why that is very much later on in the semester. But again, since this is our kind of introduction, we're just giving some vocabulary here. So molecular compounds are made of non-metals. There are no ions involved here. Big mistake students often make is that they assign ionic charges to things in molecular compounds, and that is simply not the case. Only ionic compounds are made of ions. So, for example, some ionic compounds we're familiar with: sodium chloride. Sodium is a metal, chlorine is a non-metal. Put them together, poof, now we have a ionic compound. Something like barium sulfate. We have barium, which is a metal. We have a sulfate, which is a polyatomic ion made of nonmetals, as polyatomic ions are. We also have ammonium carbonate, which is an ionic compound made of only of nonmetals, but those are ions. Ammonium is a polyatomic ion. Carbonate is a polyatomic ion. You'll want to learn those. So I'll be putting up a summary of kind of the naming rules as well as the names and formulas of many common polyatomic ions. So you'll want to really commit those to memory, because otherwise it's going to really slow you down if you don't. So these would be ionic compounds. Covalent compounds would be things like CO2 or NH3 or H2O or XeF6, xenon hexafluoride. These there's only nonmetals involved with these, no exceptions to that. And so these are completely nonmetal compounds. There's no exceptions there. We're going to see later on that they're held together not because of electrostatic interactions, but because of shared electron pairs. But that's, again, something much later on in this semester when we talk about chemical bonding in Chapter 8. So we'll be focusing on those then. In the middle of these classifications are what are called acids. Acids are special in that they have properties different from ionic and covalent compounds. They're not quite ionic, they're not quite covalent, but they're in the middle, and so they're going to have their own category. And these are made of H+, a hydrogen ion, and some anion, whether that anion is polyatomic or not, monoatomic. And lastly, they're also going to be in the aqueous state, which means that acids, for them to behave as acids, as we will define them right now, they're dissolved in water. So, for example, HCl, AQ, would be an example of an acid. We have a hydrogen ion, H+, We have a Cl minus, which is our anion, and then we indicate that it's aqueous, which means dissolved in water, by putting that AQ symbol next to it. And that's a convention we're going to use throughout this and next semester for Gen Chem, is that we'll indicate acids by putting that aqueous symbol by them. Although we will see in organic chemistry that you do not necessarily need that anymore because we don't really work with water anymore in OChem. But that's a year from now, so you can forget about that for now. Another one would be sulfuric acid, for example, or nitric acid. Notice all of these have H+. They're all going to start with H, and they're going to have some anion and then that aqueous designation. So these are just kind of our categories right now. We have fully ionic substances which are made of ions, which are metals and nonmetals put together, with few exceptions. And then we have molecular compounds, which are nonmetals only. They're not ionic, meaning there's no charges happening. And then we have acids, which are kind of in between them. So now that we've kind of looked at kind of their just classification, in the next couple of videos, we're going to learn how to name them. And you'll have plenty of time to work on your naming practice in lab, so we'll just be spending a little bit of time on it here.